Hello class, this is a video tutorial on extension trigonometric equations. To solve almost any type of trig equation, a variety of identities and equation solving techniques must be used. So I've given a quick summary here of the different identities that we'll be using. These three circled can be found on the HSC reference sheet, whereas auxiliary angles will not be found on the HSC reference sheets. Regardless, I'm going to demonstrate to you here how you might use a variety of these to solve a variety of trig equations. So let's get straight into it here. I have 5 different equations that I'm going to be solving. And for some of them, I'm going to use 2 different methods for the same question. I'm going to break this up into various videos so you can pause and attempt these and look at the different videos in different orders if you'd like. So let's get straight into the first one here. So I'm going to move this onto the next page, and that will be for the next video. So let's get straight to it. So the first method I'm going to utilize with this question is I can see that this looks a lot like the sum and difference of cosine. So to answer this, let's get straight to it. Cos of x plus pi on 3. I'm going to move this to the left hand side so we get minus cos of x minus pi on 3 equals 1 because it's still there. Expanding this, we get cos x cos pi on 3 minus sine x sine pi on 3. This is just the first expansion. We have a minus here, so minus, expanding this, we get cos of x cos pi on 3 plus sine x sine pi on 3 equals 1. Now I hope you can see that there's some cancelling that's going to happen. Cos x cos pi on 3 minus the same thing, so these two are gone, and we get minus sine x sine pi on 3 minus sine x minus sine pi on 3. So we get minus 2 sine x. Now sine pi on 3, okay, that's going to be times root 3 on 2 is equal to 1. Now from here we get negative 2 times half. That becomes negative 1 times root 3. So negative root 3 sine x equals 1. Sine x equals negative 1 on root 3. Now from here, I can see that, well, I'm actually going to answer a different question. I get theta equals sine inverse of 1 on root 3. Notice how I'm taking the positive here. Now in radians, I get this to be 0.615. So I'm going to let that equal theta. But since our domain is from 0 till 2 pi, and we're looking this to be negative, okay, so we need this to become a, what's it called, in the 3rd and 4th quadrant. Okay, so we get x is equal to pi plus theta, and x is equal to 2 pi minus theta. Okay, so now just using our calculator for this. I'm going to use a physical calculator just to get our values here. Shift sign, 1 on square root 3. Let's do this in radians. Okay, 0.615. So we get pi plus our answer. We get 3 points. So this is approximately now 3.757 as one answer, and x is equal to 5.67 something, rounding off to 2 decimal places for both 3.76 and 5.67. So these are the answers to this equation here. Now this is just one method. Now I'm going to show you how the beginning of this problem may look different, but we still come to the same conclusion. Okay, so let's utilize the product identity this time. Now, let's take a look at how we might tackle this. I hope you can see that, well, we start in the same position here. Okay, now from here, notice how we have cos x plus, well, it's a plus b, or actually no, let's actually move this around a little bit. I'm going to multiply everything by -1. Okay, so we get the other way around this time, like this. So I multiply by -1, which means I get -1 this time. But notice here we get a minus b minus a plus b is equal to this. Well, rearranging this, if we go 2 times this, it's equal to what we have here. So now this concludes to us as 2 sine of a, which is x, times sine of b, which is pi on 3, equals -1. Notice how this point is this one here, because now when we expand this, we get 2 times sine x times root 3 on 2 equals -1. And now at this point, it is identical to this point of the equation. And then from here, you can continue as normal, which I'm not going to show, because we will get the exact same conclusion as shown here. The main thing I wanted to highlight is, depending on how you see the problem, you can have a different beginning as shown here, but you most definitely should come to the same conclusion. Alright, so that's the end of this first example. Hope that gave you an insight into how we could use a variety of these identities to tackle the same problem. Hope to see you in the next video where we tackle these next 4. Hope to see you then. Best of luck.